Hello dear friends, welcome to my channel. Today's discussions is preprocessors, array and double array. So friends, this video is very large. This video is volume is minimum 1 hour, but I want to create because this is my last sessional videos because I will create another for two months later. So I will create new videos. So no problem. So my discussions is preprocessors. So features of the preprocessors are macro expansions, file inclusions, conditional compilations, and miscellaneous directive. So let us understand these features of preprocessors one by one. Okay, so first example is macro expansions. Okay, expansions. So at first, I have to discuss the C probability of processors is exactly what its name implies. It is the program that pre-processes our source program before it is paused to the compiler. Pre-processors comments from what can almost be considered a language within C language. We can certainly write C programs without knowing anything about the preprocessors or its facilities. But preprocessors is such a great convenience means that virtually all C programs rely on it. That chapter explores this video explores the preprocessors directive and discuss the pros and cons of using them in programs. So friends, you see this is the example of macro expansion. In this program, instead of writing 25 in the for loop, we are writing it in the form of upper, which has already been defined before main. Okay, in here I do not write 25, I just write upper, and which has already been defined before main through the statement. So preprocessor, when I use, so I run the program, you see that 1 to 25 you get. Okay, but instead of 25 I write only upper, and upper is defined as a functions. Okay, I hope it is clear. Now I define that is the star hash. Now sorry, in this program, instead of writing 25 in the for loop, we are writing it in the form of upper, which has already been defined before main through the statement hash define upper 25. This statement is called macro definitions and more commonly just a macro. What purpose does it serve? During pre-processing, the preprocessors replace every occurrence of upper in the program with 25. Here is another example of macro definitions. So another definition is not upper. I will write in here pi. Okay, pi 3.415. Okay, in here you see, you will check that 1 to 1 to 5. Okay, this is my okay output I will change, and void main float. This is the 3 point. Okay, 145. It is also float, not int. So I write float r equals to 6.25, and float area comma, and area equals to I I star R star R. Printf area of the of the circle equals to if area. This is my program, and what is the output? Output, we will check the output. Run the program. Area of the circle is 0.00. So friends, upper and pi in the above programs, you see upper and pi in the above programs are often called macro templates, whereas 25 and 3.145 are called their corresponding macro expansion. When we compile the program, before the source code passes to the compiler, it is examined by the C preprocessor for any macro definitions. Okay. Now you will check the R value is 6.25. Then area of circle is this. We find out the area. So it goes through the entire program in search of the macro templates. Where, Wherever it finds one, it replaces the macro template with appropriate macro expansion only. After this procedure has been completed, is the program handed over to the compiler. In C programming, it is customary to use capital letters for macro templates. This makes it easy for programmers to pick out all the macro templates and when reading through the program. Note that the macro templates and the macro expansion are separated by blanks or tabs. A space between hash and define in is optional. Remember that a macro definition is never to be terminated by a semicolon. Okay, we never terminated by semicolon. Now $1 million question: why you start defining in the above programs? What have we gained the substituting pi for 3.1415 in our program? Probably we have made the program easier to read. We have made the program easier to read. Even 3.1415 is such a common constant and easily recognizable. There are many instances where a constant does not reveal its purpose so readily. For example, if the phrase, okay, I can give a lot of examples. So this is the define define is directive. Hash define is directive. In short, it is nice to know that you would be able to change values of constant at all the places in the program by just making a change in the hash define directive. This convenience may not matter for small programs shown above, but the same purpose could have served had we used a variable pi, small p and small I, small alphabet p, instead of macro template capital P capital I. A variable could also have provided a meaningful name for a constant, permitted one change to affect many occurrences of the constant. It is true that a variable can be used in this way. Then why not use it for three reasonable? It's a bad idea. Okay, firstly, it is insufficient since the compiler can generate faster and more compact code for constants than it can for variables. Secondly, using variable for what is really a constant encourages. So friends, now I give another example. Start defined directives is properly used by C programs. Now I try to give some example another example. A and D, A and D and and define define capital O R capital O R okay, not double I. 1 minute is writing. Okay, capital O R and void main. Okay, not word and double and arrange. I write it is better. ARNGE, arrange. Arrange A less than 25 less than 25 and capital A N D and okay, and A less than 50. So void main int A equals to int A equals to 30 and if 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 arrange, and this is the example of the macros. So what we see, that we see int a equals to 30, so printf within range, out of range, so just click. So what I get within range, because as a equals to 30. Okay, now I just change this number. This number is 55. So what I run the program out of range, because a less than 50. Okay, but it is 55, so it is out of range. This is the example of the macros. It is the very interesting, friends, that this example is very interesting. Now I will show another example, which is macros with argument. Okay, so in here define area. Okay, so start to write another example that is more clear, that are the macros with argument. Okay, so what we get, 3.14 for star x. Okay, 3.14 star x, and start for float r1 is equal to 6.25. You can give any radius. Okay, so r2 equals to, I took this radius 2.5 comma a semicolon, and a equals to capital R E A, area R1 printf /n area of circle equals to percentile f. And backspace, in here I write another, a equals to capital R E A, area R2 printf /n area of circle equals to f, comma a. So we get the result in here very soon. Let's see. Yeah, area of circle, this value and this value. So this is my defined area, the argument area x 3.14 star x. So the macros that we have used so far are called simple macros. Macros can have arguments just as function can. Here is an example. This example is clear. In this program, wherever the preprocessor finds the phrase area x, it expands it into the statement 3.14 star x star x. And how about that is not all the it does. The x is macro template. Area x is an argument that matches the x in the macro extension 3.14 star x star and x, and the statement area r1 in the program cause the variable r1 to be substituted for x, thus the statement area r1 is equivalent to 3.14 r1 star r1. So the above source code has passed through the preprocessors. I hope I can give some. I can explain the macros. Okay, so friends, this is very interesting. And macros versus function, I will try to macros versus function. Macro was used to calculate the area of the circle. As we know, even a function can be written to calculate the area of the circle. Though macro calls are like function calls, they are not really the same things. Then what is the difference between the two? In a macro call, the preprocessor should replace the macro template with the macro expansion in a stupid unthinking literal way. As a as against this, in a function call, the control is passed to a function also along with certain arguments. Some calculations are performed in the function and useful value is returned back from the function. This brings us to a question: when is it best to use macros with arguments, and when is it better to use a function? Usually macros make the program run faster but increase the program size, whereas function make the program smaller and compact. If we use macro 100 times in a program, the macro expansion goes into our source code at 100 different places, thus increasing the program size. On the other hand, if a function is used, then if it is called from 100 different places in the program, it would take the same amount of space in the program, but passing arguments to a function and getting back the returned value does take time, would therefore slow down the program. This gets avoided with macros since they have already been expanded and placed in the source code before compilation. Thus, the trade-off is between memory space and time. Moral of the story is, if the macro is simple, sweet like in our examples, it makes nice shorthand and avoids the overheads associated with function calls. On the other hand, if we have a fairly large macro, it is used fairly often, perhaps we ought to replace it with a function. If memory space in the machine in which the program is being executed is less, then it may make sense to use function instead of macros. By doing so, the program may run slower, but that will need less memory space. So friends, let's start to practical discussions array. So I have already written a example that find average marks obtained by a class of 5 students in a test. One test, 5 students get marks. So how can you find out the average? So hash include studio.h sum average sum equals to 0. Okay, sum plus marks I. Okay, in here some little bit mistake in average. Sum equals to sum plus marks I. Marks I. So friends, you get that the 5 marks. So again I will try. This is the run. I run the program. Enter marks 6. Enter marks 8. Enter marks 7. Enter marks 6. Enter marks 10. Average 32.3276. This shows the average marks. Percent D average. So sum equals to sum plus marks I. Okay, so this is the one example that you can find out the average of the 5 students. But it is helpful that if the suppose the total students is 30. Okay, if the total student is 30, so you can get 30 students. You can easily find out 30 students. So to begin with, like other variable, an array needs to be declared so that the compiler will know what kind of an array and how large an array we want in our program. We have done this with the statement int marks 5. Here int specifies the type of the variable, and just as it does with ordinary variable, the word marks specifies the name word marks specifies the name of the variable. The 30 however is new. Sorry, the 5 however is new. 5 tells how many elements of the type int will be in our array. This number is often called the dimension of the array. Okay, this 5 within the third bracket, this is the dimension of the array. The third bracket tells the compiler that we are dealing with an array. Accessing elements of an array once an array is declared. Let us see how individual elements in the array can be referred. This is done with subscript. The number is bracket following the array name. This number specifies the element's position in the array. All the array elements are numbered starting with 0. Thus, marks 2 2 is not in the second element of the array but the third. In our program we using the variable I is I as a subscript to refer the various elements of the array. These variables can take different values and hence can refer the different elements in the array in turn. This ability to use variables to represent subscript is what makes arrays so useful. Here is the section of the code I equals to 0. I less than equals to 4 I plus plus enter printf slash n enter marks and scanf percentile d at the rate marks I, and the for loop causes the process of asking for and receiving a student marks from user to repeat 30 times, sorry 5 times, repeated 5 times. The first time through the loop I has value 0 and scanf function will cause the value type to be stored in array elements marked 0 and the first element of the array. This process will be repeated until I becomes 5. This is the last time through the loop, which is good thing because there is no array element like marks 5. In scanf function we have used address of operator and on the element marks I of the array, just as we have used it earlier on the variable at the rate. For example, in so doing, we are passing the address of this particular array element in the scanf function rather than its value, which is what scanf requires. Reading data from an array. The balance of the program reads the data back out the array and used it calculate the average. The for loop is much the same, but now the body of the loop causes each student's marks to be added to a running total stored in a variable called sum. When all the marks have been added up, the results divided by 5, the number of students to get to average. For I is equal to 0, I less than equals to 5, I plus plus, sum equals to sum marks I this portion. Okay, I am talking about this portion. So sum equals to sum divided by 5 printf slash n average marks percentile d average. To fix our idea, let us revise whatever we have learned about arrays. An array is a collection of similar elements. The first element in the array is numbered 0 and the last element is less than the size of the array. Okay, first element is 0 and size of the array size is 5, so it is 4. And an array is also known as subscripted variable. Before using an array, its type and dimension must be declared. However big an array, its elements are always stored in contiguous memory location. This is very important. This is very important point which we would discuss in more details later on. So more on array. Array is a very popular data type with C programmers. This is because for the convenience with which array lend themselves to programming. The features which make arrays so convenient to program would be discussed below along with the possible pitfalls in using them. So friends, I give one example of array. So now I try to give another example, passing array elements to a functions. Okay, so passing to an elements. So void passing to a element or a function. So I write in here another function. Okay, passing array elements to a function. So it is void okay void 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 display int. Okay, void display int and semicolon, void main. So int I, okay, int I, this is the one of the, okay, int I and int marks. Okay, marks should be right in here. I write in here marks. Okay, in the 55, comma 65, comma 75, comma 56, 56, comma 78, comma 78, comma 90. For loop I equals to 0 to I less than equals to 6 and I plus plus, and display 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 marks display marks voice display int m. Okay, so printf okay, this is the one of the example. So where is the error is showing display marks. Okay, in here I should be in here. Okay, another error, display marks I. Okay, int m. Okay, next error, display marks int m, void display. Okay, in here no comma in here. Okay, next is 78 in here 9. Okay, this the writing is not possible. 90. Okay, I plus plus, I less than equals to 6, I plus plus, display int marks, display void int. Okay, int m. Let's see, 9, display marks o. In here it is not display, it is display play marks. Yeah. So friends, let's run our program. So you see that 55, 65, 75 and 56, 78, 70, 90. So I just correct my program. I corrected my program and you will see that my program is running. So we are passing an individual array element at time to function display and getting it printed in the function display. Note that since at a time only one element is being passed, this element is collected in an ordinary integer variable m in the function display. Now the call by reference. Now friends, I use pointer. Okay, passing pointer. So passing pointer, now you will check this way that I just write in here int star and I and display at the rate addressing mark I and int m star and printf m star. So we change everything. Now we get the run the program, we get again same values. So we are passing addresses of individual array elements to the function display. Hence the variable in which the address is collected in is declared as a pointer variable. So friends, we have explored arrays with only one dimension. It is also possible for arrays to have two or more dimensions. The two-dimensional array is also called a matrix. Here is a sample program that stored roll number and marks obtained by students side by side in a matrix. So hash include stdio.h. Okay, yeah, you have seen my writing. Okay, so there are two parts of the program. In the first part, through for loop we read in the values of roll number and marks, whereas in the second part, through another for loop we print out these values. Look at the scanf statement used in the first for loop. Scanf's %d stud student I 0 and student I equals to 1, I and 1. This is this two portion, I 0 and I 1. Okay, and in stud I 0 and stud I 1, the first subscript of the variable stood in the row number and which changes the for every student. The second subscript tells which of the two columns are talking about. The zeroth column which contains the roll number and the first column which contains the marks. And remember, the counting of rows and columns begin with 0. The complete array arrangement is shown. Okay, let's start to run the program. Okay, let's run the program. So friends, let's run the program. So enter roll number and marks. Okay, so the first subscript of the variable stood. So far enter roll number and marks. So friends, let's start. Write roll number 1. I can write in here marks 89. Okay, against roll number 2. So enter roll number and marks is 2. So we get again. So we can write the marks. Okay, roll number 2 and marks we can write in here the second column 9, 8 and in here I write the marks is 46. Again I get, so enter roll number and marks. So this way I get, okay, 2, 8 and 46. So if you check that stud 0 comma 0, you get a column and row. So the above arrangement highlights the fact that a two-dimensional array is nothing but a collection of number one-dimensional array placed one below the other. So first column which contains the marks, remembering the counting of rows and columns begin with 0. So this is the way 4 and 3. So in here you get the result is 8 and 46. Enter the roll number marks. In here you can write, so 220022. So this way I can write 1122, this way. Okay, so I hope I can clear this. I can give one example of the double array example. Thanks for watching.